Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the case when this U-tube is being rotated. So in the first case, let us see the situation in which this U-tube is rotated about an axis passing through its one arm. So like this U-tube is being rotated with an angular velocity of omega. So we have to find out this h, height difference of liquid levels in the two limbs. So I'll be explaining two methods to solve this question. So let us consider this point A and in this point B. So in the first method, we have already studied the fact that when a closed tube containing some liquid is being rotated about this axis with some angular velocity omega, then we know that the pressure at some random point at a distance of r, p, will be equal to p axis plus rho omega square L square or r square by 2. This we have already studied. So again we can say same thing, that pressure at B will be equal to p axis. Now A point is itself situated on the axis, so we can say that p axis is PA plus half rho omega square into L square by 2. We have already written this too. So PB minus PA will be equal to half rho omega square L square. And obviously PB minus PA will be equal to H rho G. So it is H rho G, that is equal to half rho omega square L square. And H is equal to, cancelling rho with rho, this is omega square L square by 2G. Now in the second method, we have already studied in the last video that when a container is rotated filled with the liquid, then the liquid surface becomes paraboloid, and the two-dimensional form of paraboloid is parabola. So if we draw the parabola, and we also know that the base of that parabola is on the axis. So this parabola would be like that. This is the parabola, and in this situation this height is h. We have already studied that h is r square omega square by 2g. This formula we have already derived in the previous video. You can refer the previous video. So in this case, this h is capital H, and capital H will be equal to r square. Now r is this length L, so L square omega square by 2g. So this will be the value of h. We have already verified this value from the method 1. Now in the second case, in this case you can see that this tube is being rotated about an axis which is not passing through any arm. In fact, this axis is asymmetrically placed with two arms. So this distance is L1 and this is L2. Now this point is A and this point is B. So if we again, and we can assume that the pressure on the axis will be P axis. This is P axis. So we can say that PA will be equal to P axis plus half rho omega square into L1 square, and PB will be equal to P axis plus half rho into omega square into L2 square. Now PB minus PA. PB minus PA will be equal to half rho into omega square into L2 square minus L1 square. And we know that PB minus PA is H rho G. So H rho G will be equal to half rho omega square into L2 square minus L1 square. Cancelling rho with rho, H will be equal to omega square by 2G into L2 square minus L1 square. This is the value of H. Now if we discuss the second method, then we can first of all draw the shape of the free surface, the equipressure lines. So it would be like that. Okay, because we know that the base of this parabola is on the axis of rotation. So this value is, this is H1 and this is H2. So H1 is formula is r square omega square by 2g. So H1 will be L1 square omega square by 2g, because the value of r for point A is L1, and H2 will be equal to L2 square omega square by 2g, and capital H is equal to H2 minus H1, so it would be omega square by 2g is common, and this is L2 square minus L1 square. So this is again the same thing which we have already verified by method 1. Now in the third case, in this case you can see that by some external rod we are rotating this tube about this axis. So the distance of this arm of the tube from this axis is L1, and the distance of this arm of the tube from this axis is L2. So what we can say that obviously by method 1, this is A, this is B. So by method 1 we can say that PA will be equal to P axis. We are assuming that there is some liquid filled in this tube. So PA will be equal to P axis plus half rho into omega square L1 square. Now PB will be equal to P axis plus half rho into omega square into L2 square. Sorry. So PB minus PA will be equal to half rho into omega square into L2 square minus L1 square, and half rho into omega square into L2 square minus L1 square will be equal to H rho g, because the difference of liquid levels between the two arms is H, and the pressure difference will be H rho g. So cancelling rho with rho, H will be equal to omega square L2 square minus L1 square divided by 2g. This is the value of H. Now by method 2, we can draw the surface. So the equipressure line would be like that. You can imagine the equipressure line, and this height is, let's suppose it is H1, and this height is H2. So H1 will be omega square r square by 2g, so it would be omega square. Now r will be L1 square by 2g, and H2 will be omega square L2 square by 2g. So H2 minus H1 is obviously H, and it is equal to omega square by 2g and L2 square minus L1 square. So H will be equal to omega square by 2g, and this is L2 square minus L1 square. So this is the same value of H which we have already derived from the first method. So guys, that's it in this video, and in the next video we are going to discuss the pressure and torque acting on the gates of the dam or a container filled with liquid. Thank you.